All right, we're going to try that again. Good afternoon, hackers. We're going to get started on the next workshop. So this one is going to be on how to prototype 3D enclosures for your projects, and specifically using a piece of software called SolidWorks. So, oh boy. As you all are reaching the final stages of your projects, then you might one thing that you might be starting to consider is how you're going to present your creations, especially when it comes to hardware, and how to wrap it all together and make it into a nice little package so that it's not too hacky, but just hacky enough. So today what we're going to be doing is we're going to be giving you a brief introduction into a 3D parametric CAD software called SolidWorks to create different enclosures for your projects and kind of show you how it works to create those things. And then we're also going to touch a little bit on how to slice models that you create so that they can be 3D printed and rapidly prototyped. So the workshop today is going to be very heavily demo based, and I believe this is the end of the slides, so I'm going to get switched over and get right into it. So yes, as I said earlier, then this is going to be done in SolidWorks, which is a parametric 3D CAD software that is used in industry and is very similar to a lot of other parametric 3D CAD, but we're going to be using this one because it's relatively affordable and it happened to be what I already had. Today what we're going to be going through is we're going to be going through a demo to design a simple enclosure for a Arduino Uno board, and kind of go through the process on how you would design it from the ground up and then get it printed off and prototyped for your projects. So here, as you can see, you can see, is SolidWorks. So with the goal of today, we're going to design an enclosure for this Arduino Uno, and we are going to do so using measurements for predefined measurements for ease of use. Typically, how the workflow would work would be that you would tend to take the board that you have or the thing that you've created and sketch out all of the dimensions of it to get a rough draft of the size and dimensions of what you need so you can design an enclosure for it. But for the sake of the demo, then we're going to use these dimensions as provided off of SolidWorks education products. So, yes, I guess let's get into it. So with all parametric 3D CAD software, then what the workflow looks like is rather different than other 3D modeling software that you may or may not have seen or used before. If you've used software like Blender or things like that, where it's a rasterized 3D rendering software, this is quite a bit different and a rather different workflow and a mindset that you have to get into when designing things. So one of the first things that you do with parametric CAD is you design 2D sketches of the objects that you're going to create in 3 dimensions, so you have a foundation for which you can create the 3-dimensional objects so that it's a little bit easier and more sane to do. So with that in mind, getting started, then we're going to, the first thing that we're going to do We're going to create something called an outline or a shadow of the board that we want to create an enclosure for. So it'll end up looking somewhat similar to these technical drawings of the Arduino Uno, just a lot more simplified and in rough 3 dimensions so that we get a rough idea of how big it is for fitting. So how this ends up looking is that we will first create a 2-dimensional sketch on a plane. So this 2-dimensional sketch, again, will be the foundation of our 3D enclosure once as we create it. So let's get into it, and I'll just try to kind of narrate what I'm doing and why I'm doing it as I go through and design things out. So to start off with, we're going to create a rough rectangle of the board because that's the shape it's in. And the important parts of this board that we care about for the purposes of this workshop is we're going to want to be able to mount it to the enclosure. So as you can hopefully see, I believe, let's zoom this in a little bit. The Arduino Uno has 4 mounting holes, in the 2 on the top and 2 kind of roughly towards the bottom. And it has 2 plugs that we are going to expose in the enclosure, and that'll be the USB port as well as the power barrel, power jack. So those are the things that we're going to represent in the model so that we can make affordances in the 3D model for it. So to do so, what we start off with is very rough shapes of those objects that we will slowly refine as we go along. So we're going to create a couple of circles to represent the mounting holes towards the top and the bottom, as well as a couple of squares to represent those ports that we want to expose. And one of the rather useful parts of parametric software is that everything is defined, as you might expect, parametrically. So as you go through, you're defining constraints and dimensions of the objects that you're creating. And the software is smart enough to be able to handle different series of rules and constraints to represent all the dimensions of your object. So what we're going to do to start off with is start getting these dimensions in to our outline. So as we can see here, the board is about 68.58 millimeters, 68.58 in length, and the width is 53.34. So what we're doing here is we are 53.34. We're defining these dimensions as well as providing a little bit of an annotation so that we can see what size things are. Next, we're going to do the size of the holes. So the diameter of these holes is 3.18. So let's do that. And another rather powerful thing about parametrics CAD is that you can define relations of objects to each other. So here, what we with these holes punched into the board, then we want them to be all the same size because they're all 3.18 millimeters in diameter. So we can tell SolidWorks that they're all the same size and have that as a relation or a constraint on those objects. So that when one changes, then they all have to follow the constraints and all be equal size in this case. And that sizing will be 3.18 millimeters in diameter, and we have to divide it in radius, so that would be 1.59 millimeters radius. All right. And next, then we're going to roughly position them. 17.78. And then we have the next dimension for this one. This hole is 7.62 millimeters from here to here. 17.62. And so as you can see, as you go along with the start of a project, you kind of go through and you slowly define all these dimensions until things are in the places that they need to be. And there's, I guess, two different kind of parts to it. So you want to define, usually for 3D enclosures, then it's good to define the footprint of it on the one end, as well as in another dimension. So you get kind of two slices in the different dimensions, or perhaps even three, of the outline of the object. So with that, we're going to move over to a different dimension and outline the profile of the board. And what we're doing here is we're creating another sketch in this on this other plane, the XY plane, to define that profile. So looking back to our technical drawing, then we can see that with the profile, then the important parts that we're looking for is the profile of the ports, as well as the thickness of the board that we want to pay attention to and take into account of. So with that, we're going to create the thickness of the board. Gonna redo these. And start defining the dimensions of them. So this sport is 12.4 millimeters, and the other one is 9, so we can define those. And the thickness of the board itself is 1.65 millimeters. And so that's, this is kind of the rough approximate workflow that you would do to create the outline. For brevity's sake, then I've created a template outline that I went through and filled out already that we can jump to show you what it looks like after we go through and define all the dimensions of everything. If we go open. So we can see we have the dimensions of this board outlined in both the XY plane and the XZ plane. And we can take a quick look of roughly what that looks like. So again, it's approximately what the technical drawings have, ignoring certain aspects that we don't care about as much, because we just want a rough outline with the appropriate dimensions in the two planes that we care about, which would be these two. So once we're done with that, we want to start the actual 3D portion of designing a 3D enclosure for the board. So with that, we're going to quickly create a center point line for this so we can find center. And then we'll create another sketch on the top plane. So this next sketch will be to will be the base of the case itself. So with this case, then we want it to be obviously larger than the board and to kind of fully encapsulate it. So we'll do something along the lines of this. And then we'll start defining the relations of the base of this with the board that we've kind of mocked up. So we're gonna make sure that they're aligned in the center, or like aligned vertically, rather. So this will lock them in place vertically. And then we also want to we want to find the dimensions of the case that we want. So with that, we want to be able to access these ports. So we're going to have maybe a 1 millimeter gap here so that the ports are easily accessible. And we're going to define the width of the case to be maybe 85 millimeters or so. And the length to be, let's say, 100. Maybe a little bit less deep. We'll go with 90. So then with that, we have this, the base of our 3D model sketched out, and we're going to finally move from the 2D sketches into working with 3 dimensions. So we're going to do something called extruding this out. So we're going to give it height in the y-axis, which we can define as being, let's go 30. We want a case that's 35 millimeters tall or so. Something like that. And we're going to want to offset to account for things like standoffs and the width of the board itself. And maybe giving 10 millimeters or so space for that. The opposite direction. Okay, yeah, that looks like a reasonable box to put our case in. There's a reasonable box to put our board in. And then the real power of parametric CAD is when the functions that it provides for creating objects. So there's a whole host of features and things that you can do to transform your really fundamental objects into things that you would expect to see when you're fabricating objects. So for this case, then obviously we want it to be hollowed out so that we can put things in it, so it's not just a brick. So for that, we're going to do something called shelling it out the box, which will create a, as it kind of just what it says on the tin, of a shell around the interior, turning the box into more of a shell. Let's show a preview of that to see what it looks like. So we're going to do maybe a 5mm wall thickness around the board. That looks fine. Start off with that. And now we have to, now that we've shelled it out, we can notice that the board is clipping into the wall of the shell a little bit. So what you can do is, in parametric CADs, then there's a sort of a history that's kept of all of your objects. So what you can do is you can go back in history and you can edit things, and it will try its best to propagate those edits, and while maintaining all of your constraints and relations. Initially we had set that it was a 1mm gap between the board and the edge of the case, and we need to move what edge it references. So right here, we're going to get rid of this constraint of 1mm here, or rather, we're going to just adjust it to 6mm to account for the width of the walls, and then we'll propagate that in. All right, so now we have a rather blocky case looking object. So let's make that a little bit nicer to look at and maybe nicer to hold. So let's round out the corners here so that has a nice aesthetic to it. Grab anything shouldn't have. Let's go. Can be a little bit finicky to click on all of the correct objects that you want to click on when it starts to get a little bit noisy. So again, we're going to jump into the features and perform a common operation or function that is done, called a fillet or fillet or whatever it's called. Where would that be? Right here. And what this does is it just rounds out hard edges using a radius that you define. So we'll go with a 5mm radius, and so that looks like. And that looks fine. So we rounded out the corners, makes it look a little bit nicer. So now what we want to look at is, so this case for the board, then we want to be able to enclose it fully. So what we're going to do is we're going to insert screw holes so that we can screw it shut when we're done. So let's do that. So for that, what we're going to do is define little support pillars or standoffs that'll have a hole in it so that you can screw into it. And again, when you do anything with with parametric CAD, and you want to start off with an outline or a 2D sketch of what you want to do, and then slowly work it into 3 dimensions. So for that, what we're going to do is we're going to sketch up on the base of this. So let's define the standoffs here. We'll do these little pillar things in corners. And again, we just start off with a rough approximation of what we want it to look like and slowly narrow it down into the shape that we want. So with all of these, we want them to be all symmetric and the same size. We had a relation to say that they're all equal to one another. So they remain the same size, and let's say we'll give them a radius of 6 millimeters or so. Maybe not that large. Let's go. So yeah, we're going to start defining more parameters about these. So let's see. We want the edges of these circles to coincide with the corner of the case. So we're going to add a relation to each of them so that they do that. So we select both the corner of the case and the circle and say that they're coincident with one another, and that's the relation that they hold. And it snaps it to the corner so that they're touching. And we're going to do that with each of them. And then, as we can see there, some of them are a little bit not equally distributed amongst the corners of the case, so we're going to set a parameter to restrict the amount of space in between the circle and the edge of the case. And let's say that's 8 millimeters maybe on both dimensions. And so then we can see that it's nice and evenly distributed on both sides of the corner. So we'll do that again for all 4 of them. And then we'll have some nice, a nice sketch of the standoffs. So once you start going through things and defining constraints, one thing that you'll inevitably run into is when you over-define a sketch. And when you overdefine something, it's you're doing more work that's necessary. So when there's only 1 degree of freedom that SolidWorks has for any given thing, then it can infer what the dimensions are of that thing, and you don't need to define it because it's trivially calculatable. All right, so we have all of our standoffs now. So we want to, again, once we have a sketch, we want to bring it into, 2D sketch rather, we want to bring it into 3 dimensions. And to that, we're going to extrude it out. That's a little bit too tall. All right, that looks nice and flush. And we'll extrude it out. So now we have these kind of integrated standoffs into the side of the case. So let's go through and insert some screw holes for them so that we can eventually screw on a lid to the top. Which, again, so we're going to start off with a 2D sketch. And then start defining some small circles that will be the mounting points. And we'll say we're working with 1.5 millimeter or so radius screws on the inner diameter. And again, we want them all to be the same diameter or radius because we want to use the same screws and not different screws. So we're going to constrain that. And then we're going to define the distance from the screws to the sides so that they can be nice and centered. We'll use the same 8 millimeter center point that we used on the columns so that they are center aligned. All right. So now we want to extrude it in, or we want to bring it into the into 3 dimensions. But instead of being additive this time, we're going to be subtractive because we want to create an insert for the screws. So for that, we'll use a different function that is the extruded cut function. And we'll create 15 millimeter screw holes in length. And so right now it's cutting towards the bottom. So we just want to change where that's from to the top here. So it just cuts down. And it's going to perform that for all of them. So we'll see that it cuts down to about halfway, or 15 millimeters down. And now we have screw holes that we'll be able to use. So next we want to do the same for the board. We want to create some offsets or some standoffs so that we can screw the board down. So we made a little bit of space for them. We're going to do the same thing. We create standoffs and screw holes so that it can be mounted down, which will be the same as before, where we go back to 2D sketch. And then create the standoffs. Then we want them all the same size, so we constrain them to be equal. And then set the size of them all to, let's say, 5 millimeters radius, maybe. It's a nice large standoff for them. And bring it into 3 dimensions by extruding it out. So we want these to be rather short, so it'll be 4 millimeters tall, so that it lines up with the bottom of our board. And we can check with it using the outline, which is why the outline is rather useful, even if it is a little bit tedious to create. It helps kind of ground us in where things are at. Then we're going to punch some holes in it for screws, using a similar process to the other screw holes. And we'll just have these be the same size as the holes on the board. And then we want to cut out the materials for the screw holes. And we'll cut out 4 millimeters. Actually, let's adjust that so it's a little bit deeper, which is the affordance that we get is that we can always go back and adjust. So we'll bring it fairly low down. Perfect. So we have all the screw holes in place. For the board, so the last thing that we need to pay attention, or the last thing that we need to take into consideration is the ports for the case, so that we can access both the power jack as well as the USB serial cable. So we need to cut some holes inside here. Which will be the same with doing a two-dimensional sketch. Go through and create a slightly larger outline of these, the size of these ports, so that they can kind of fit in, but not be too tight. So we'll give them a 1 millimeter on all sides wiggle room, so there'll be 2 millimeters on both sides, just to make sure that we're not making things too tight and then nothing fits in the end. And then we're just going to cut out a hole in the side here for those. So we're going to cut in through the side here. And there we go. So we have these two ports for it to be able to place in. So this is the entirety of the bottom part of the case. So we have these stand-offs so that we can screw the board into the bottom when we place it in and access the two parts that we want. So the last thing to do is to create a top for the case so that we can enclose it fully. So for that, what we're going to do is we need to save this and create something called a new part, because these the top and the bottom will be completely different parts, and so it makes sense to not have them all put together in one piece. So now when we are making a new part, we still want to make sure our dimensions are the same. So it's good to quickly go through and just measure a few points so that we get the right sizing for everything. So we're going to go double check the dimensions of the case. That's 90 millimeters in depth, and it is 85 millimeters wide. So we'll jump over to the new part. We'll create a top for the case. It'll be 90 by 85. We want to define the dimensions 90, 85, And then just bring it into into 3 dimensions. And we'll just have it be, well, it would be rather small at 5 millimeters tall. And then we want to create screw holes on this so that we can screw from the lid down to the base and join it together. So for that, what we're going to do is we're going to do a new sketch so we can cut out those screw holes. And the screw holes, I believe, were 1.5 millimeters in radius. And 8 millimeters away from the edge of the case. All right, so we have our screw holes in place, and we can just cut those out. Come on. And there we go. We have our screw holes, and then we just want to make it nice and rounded like we did with the other one, so we'll do the fillets. And just round it out by the same 5 millimeter radius that we did with the bottom. Ah. And so give it the same nice look, so it's not too rough around the edges. And then we'll just save this. All right, and then just the last part is to make sure that these fit well together. So what we're going to do is create something called an assembly and put them together. Oh. I think I forgot to save this. Odd. What's going on here? Build this. What's going on? Running into some difficulty getting this to render properly for some reason. But anyways, you get the point. We have the both sides of the case. So now that we've modeled it in a piece of software, one thing that we can do is we can export it out so that it can be 3D printed with for prototyping. So to do that, we just save it out as an STL file. And we do that for both the case base and the lid. And then once we have an STL file, and what an STL file is a rasterized representation of these objects, we can put them through something called a slicer to convert those objects into something that the 3D printer can print, and it tells it what path it needs to take in order to print those objects. So what you do is you just get a slicer. I'm using Prusa's slicer, but most any slicer will do. And then we just add them in. And yeah, we can just lie these down flat, and then the slicer will figure out how to tell the printer how to print them. Yeah, and then you need to set parameters in the slicer according to whatever printer you're using, and then you just tell it to slice, and it'll give you a file for which you can send to a 3D printer and print off. And yeah, so then you have a nice little case for, in this case, Arduino Uno, but for whatever your project is, then you can create an enclosure for it, make it a little bit nicer, maybe more structure, more resilient to falling apart because it'll be a little bit protected and wires won't be coming out. But yeah, and that concludes the workshop.